So as we discussed in the last class, unicast is nothing but one-to-one interaction or one-to-one data transfer. We call it as a unicast routing protocol. Multicast routing protocol is, let's say you have a 10 members we have in a group, and I want to transmit the information or I want to pass a message only for 3 members. So what I will do is, instead of sending 3 times individually, I should select them, I should make a group of 3 them, and I should transmit the data. So that we call it as a multicast routing protocol. The third one we call it as a broadcast routing protocol. So what you mean by broadcast routing protocol is, so in a group of 10 members, so if you want to transmit a message means then you will be broadcasting. Whatever the message you are going to transmit, it will be broadcasted or it will be received for all the receivers. Okay, so the difference between this broadcast and multicast is that in multicast you are going to select the group of students, only those selected group of students you are going to transmit the data. So that is all about your multicast. What about broadcast? You cannot have a selection. So if you want to transmit the data means then every receiver has to receive the data. So we say that it is a broadcast. And I told you we will be using a unicast routing protocol in most of the cases. Why? Because we want to have a information to be transmitted from point to point communication. So if you want to discuss about peer to peer communication or point to point communication means, then we will be having an interaction between individuals separately. So when you want to have a data transmission from one to one, then as I told you, because the transmitter and receiver are geographically far apart from each other, so it is not possible for me to directly transmit the data from source to destination. So what we should do is we should use the intermediator nodes which are there within the network or within the surrounding of us. So I will transmit the data to the neighboring node and the neighboring node will transmit the data to the next neighboring node. So like this, the data will be forwarded. I told you the hop count. Okay, yesterday I gave you an example. Let's say I am transmitting the data from my to, I think if I am correct, I said to Rupasri or Deepshi. Okay, so it will be passed through Deepshi and from it will go to Rupasri, like that. I told you one example, right? So means what? Depending upon the number of half count or depending upon where the location of the destination is there, the data will be routed. Okay, so therefore we should know what are the neighboring nodes are there and what is the routing table which is associated for each nodes. We need to understand so that we can successfully transmit the data between source to destination. So when you want to understand the routing table of each node, so what are the things you need to do is you need to understand how the network will be built or how you analysis the network. So in order to analysis the network in terms of picturization, we will be using a graph theory. Okay, so in last example I told you, you can see here an internet architecture or internet, some part of the internet has been represented in the diagram, and this internet how you are going to represent for the analysis or in order to create the routing table, how you depict this has been represented in this diagram. So you can see here we have routers and these routers are communicating with each other. There are two types of connection is there. One we call it as a solid line connection and one more we call it as a dotted line connection. This solid line connection we say that it is a means wired connection, whereas the dotted line connection we call it as a wireless connection. See, if I want to analysis or if I want to know so how the routing of the information will take from one router to another router within the network, then we should have a routing table. I told you. Okay, what do you mean by routing table? Routing table is nothing but who is neighbor to me and with what energy levels they are there, and if I want to transmit the data means in what way or in from which path I need to select so that I can transmit the data successfully. That is all about your routing table. So in order to build up the routing table, as I told you, we will be using a graph theory. So you can see the nodes are represented in terms of circles. That is nothing but the routers are represented in terms of nodes. And the link between, so you can see we have a switch we have used in order to connect from one router to another router. So that we have represented with a line. Okay, so that is nothing but edge. And if there is a connection between one router to another router means then that edge has to be connected between the nodes. So here you can see for all the nodes we have given the nomenclature, that is starting with A, B, C, D, E, F, G. and since there is a connection between A to B, therefore we have connected a solid line, and from A to D there is a connection is there, therefore we have connected a solid line. And also one more thing you need to do is we will be using a weighted graphs. So what you mean by weighted graph means then the amount of energy which is required to transmit from one node to another node, we will be representing in terms of weighted parameter, and that weighted parameter we call it as a cost. Okay, yesterday all these things we have discussed, just I am summarizing what we have done so that it will be easy for you to understand the today's concepts. Okay, so now as I told you, we need to know what is the weighted cost of each link. That is, if there is a link between two nodes means, then we need to understand what is a weighted parameter which is associated between the link, and generally we will be representing in terms of cost value. See this, what you mean by cost, you can ask me. So what you mean by cost is, it might be the distance or it might be the energy which is required to transmit the data from one node to another node. See, it depends upon the network where you are using and what is the geographical location you are using your network. So based upon that we can means denote this cost value. So for the time being, you assume that the cost is the distance between from A to B. So that is nothing but 2. Let's say for the nomenclature, we call it as a 2 meter or 2 kilometer we can call. See, the unit is not the matter for us. The distance is the matter for us. So therefore, we have represented the distance between from one node to another node. It is nothing but the cost value, which is nothing but 2, 3, like that you can see here. So wherever there is a link is there, so we will be associating a cost to it. So depending upon the cost, we will be creating a routing protocols. So the first one we call it as a least cost tree protocol. Or this least cost tree, what is that? We will be creating a tree from one particular node. So from that node, what are the links are available to the neighboring nodes, we need to draw it. Okay, so this we call it as a least cost trees. So in the least cost trees, what we'll be having is the source node will be present at the root, and from the source node we will be creating the leaf nodes. So the leaf nodes are nothing but we call it as a terminated nodes, or we call it as a destinated nodes. So from there we can able to identify, so what is the distance is there from source node to destination node from the use of this tree diagram. Okay, and you can see here we will be using a least cost routing algorithm. We will be using a least cost routing algorithm. So what do you mean by least cost routing algorithm is that when you want to transmit a data, when you want to transmit the data, let's say I want to transmit the data, we are in, let's say now in class totally 9 members we have. Now I want to transmit the data, let's say to Subramanya. So now if I want to transmit the data to Subramanya, I have two links with me. One is I can go from, I can give it to Deepshi. From Deepshi, it will be reached to Subramanya. That is one link I have. And one more link what I have is I can give it to Rupasri. From Rupasri, it will go to Venkat. And from Venkat, it will go to Subramanya. So now, and there is, let's say there is one more link is there, means how I can reach the Subramanya. The one more link is I can go to Jyoti and I can go to Murthy, and from Murthy I can go to Sonika Prasad and then Srinivas, and then I can go to Subramanya. Okay, so these are the 4 different paths we have. So how this least cost routing algorithm it works is, so if you have a multiple paths to reach from source to destination means, then the total sum of the cost values within that link, whatever which will come it as a minimum value, so that minimum value cost value you need to select it as a link for the data transmission. So that we call it as a least cost routing algorithm. Are you able to understanding what I'm saying? Yes, Rupasri.
Yes, sir.
Okay, so means what, if you have 3 to 4 links between the data transmission from source to destination means, among the 4 links, which one you need to select, that is the question for us. So which one you are going to select? The cost value, the total cost value to reach from source to destination, which is having minimum, no? So that I will be selecting. So therefore the name indicates that least cost routing algorithm. Okay, so this is one of the least cost routing algorithm what we will be using in most of the networking concepts in the CCN. Okay, so now you can see here how the least cost trees are created within the network. So as I told you, internet is nothing but it is all about the interconnection of the nodes. So you can see here, so we have a connection that is from A, and from the connection A, you can see the cost of connecting A to A, it is zero. Why? Because if I want to transmit the data from for myself only, there is no energy to be spent. So therefore, the cost of transmission of data particular node to itself, it will be zero. So therefore, we can see here we have written as zero. Next, from A to B, there is a link is there. So the means the cost value means the distance from A to B, we have represented as 2. So from A to D, so there is a link is there. So the distance from A to D, ETB, we have call it as a 3. Okay, so means what? This is the least cost from the node A. Okay, so the node A has been connected to two nodes. So that is nothing but B and D. And from B in turn, it is connected to E, F, G. Okay, so we will not talk about that. Just we will talk about from the neighboring nodes. Now you coming to the right side of the first diagram, you can see in the B, which is highlighted in a black color. So now you can see the B has been connected to subsequent nodes. So what are the nodes? It is connected to A, it is connected to C, and it is connected to E. So when B wants to transmit the data to A means cost value you can see here it is 2. When B wants to transmit to E, the cost value is 4. When the B wants to transmit to C, the cost value is 5. Okay, so this is how we are going to create the cost for each network. So when you come to the node C, so you can see it in the node C, it is also having three immediate neighbors. So one is we call it as a B, and one more we call it as a F, and one more we call it as a G. So this is how we create a cost tree from the internet diagram or from the internet architecture. Okay, so you can see the nodes are interconnected. So if they are interconnected means then there will be a cost is associated for the each link, and that cost will signifies the distance between the two nodes as of now. Okay, so that cost will change it later, and we will see what those changes in the later cases. But as a present instance, you assume that cost is nothing but it is a distance. So now you can see here the source node we are highlighting from the root tree, that we call it as a black color we are writing, right? So first diagram left side, so you can see here the first value, that is A, has been highlighted with the black. So means what? We are considering the cost value only for the particular A. From that particular A, we are writing the cost value for the different nodes. Okay, so therefore it has been highlighted in a black color, and the remaining all nodes we call it as a intermediate nodes, or the remaining nodes we call it as a intermediate nodes or a end nodes. Okay, so in second diagram means coming to the right side, the B is a source node. So with associated with the least from B we have highlighted. Similarly, all the diagrams has been listed over here. So this is how you are going to create a cost tree for the particular network. Okay, is that clear? uh, Length is means length, you don't assume that the both the arrow mark are same length, because of that we need to give same value, right? You are asking.
Yes, sir.
It is not like that. See, for the representation we have written like this. Okay, so as I told you, cost means the energy spent, it might be there or it might be the distance. So here, since B and C there are too far apart, so I need to write a longer arrow mark. Don't think like that. We will be just for the representation, we will be using that arrow marks. Okay, so depending upon the distance, we will not shorten the arrow mark or we will not enlarge the arrow mark. We will not do like in this network architecture. Okay. So all lengths
Yes,
are
sir.
same only for the picturization, but we will be writing the cost in terms of number only. So through that number, we can come to a distance, not with the use of the length of the arrow. Is that clear?
Yes, sir.
Okay. So don't think like the if I write a longer arrow means it is the distance is more. If I write a shorter arrow means the distance is less. Don't think that. Just for the picturization, we will be using those arrow mark. But the cost value, so whatever the value we are writing on that particular edge, so that is the distance actual. Okay. Shall we go next?
Yes, sir.
And two important things what you need to remember is when you want to go for the least cost tree algorithm, let's say when you want to find out, just wait a minute. See, when you want to find out, let's say I want to have a path. So what is a path? I want to find out the cost value from A to G. Let's say I want to find the cost value from A to G. So A to G, you can see the first diagram, how we can reach from A to G. I can go to B, from B to I can go to E, from E to I can go to F, and from F I can go to G. Okay, so this is the path I can select if source node is A and if the destination node is G. Okay, what is the path from A to B, B to E, E to F, F to G? And what is the total cost of that? You need to find out. So, what is the total cost of that? 2 plus 6 plus 8 plus 9. So, this is the total cost of this path from reaching from source node A to G. Okay, so this can be divided in like this. How? From A to B, I will create one path. From E to G, I will be selecting one more path, or I will be using that link. Okay, so single link only we can get it, but we can do the division like this also. So how? From A to B, I can represent it one path. From E to G, I can represent it another path. So what I'm trying to say is that in a given path, you can divide that path into some subsets, or with a shorter length paths you can create. So that is the first thing. And you can see here the cost of reaching from A to G, it is same as the cost of reaching from G to A. Okay, because they are reciprocals to each other. If I spend the distance between from me to someone, if it is 5 kilometers, then the distance between from someone to me, it will be 5 kilometer only. So means the same thing we will be applicable in the least cost tree also. So the cost value from reaching from source to destination, if it is 15 means, then the cost value from reaching from destination to source, it will be 15 only. So that thing you need to keep it in mind when you're analyzing this tree diagram. Okay. So based upon this, so we will be creating a routing table. So one of the first routing table based upon the cost value we have created is called as a distance vector routing table. We call it as a distance vector routing table. So what you mean by distance vector routing table is, see, the link which is having a least cost, so that cost that link I need to select for the data transmission. So that we call it as a distance vector routing table. So what it does is, so when I want to transmit the data from source to destination, which one is the minimum distance is there for me to reach from source to destination, that link I need to select. So that is the principle behind in the distance vector routing algorithm. I need to select the best routing table, or I need to select the best routing link, so that the distance to reach from source to destination, it has to be minimum. So such an algorithm we call it as a distance vector routing algorithm. And in this distance vector routing algorithm, one of the important equations what we are going to use, that the equations we call it as a Bellman's fold equation. We call it as a Bellman's fold equation. And one more thing you need to remember is, so when I say an internet, the internet works on two circuits. One we call it as a packet switching network, and one more we call it as a circuit switching network. What do you mean by circuit switching network? See, there is no dedicated link will not be there between the nodes, and the nodes are moving from one station to another station, or from one geographical location to another geographical location. So let's say if I measure, now I want to transmit the data, I want to measure who is neighbor to me so that I can transmit the data, or I want to know who are all there and how I can reach the other nodes I want to calculate, let us assume. So if I want to do that, okay, at let's say now the time is 9:30, so I will measure the values. So from me to Rupasri it is 5 kilometers is there, from me to Jyoti it is 3 kilometers is there, and from me to Subramanya it is 10 kilometers is there, and from Venkat it is 15 kilometers is there at 9:30. And since we are dynamic in nature, the uh, the the due to dynamic in nature, So the distance will vary. So now what the Venkat will vary means he may go somewhere. So the distance between me to Venkat initially it was 15 kilometers. Now it has reached to 20 kilometers. So means what? Because of the dynamic nature of the nodes, this routing table will keep on changes. This routing table will keep on changes. So what we should do is instantaneously or with particular instant of time, we need to update the routing table or we need to update the surrounding information of the nodes. So that surrounding information of nodes, the routing table updation will be used in the distance vector routing table. So in the network, they will maintain or they will have set up one specific time, that is, let's say around 10 for every 10 milliseconds or for every 10 seconds, the routing information has to be updated. So means what? The distance from current node to the neighboring nodes, it has to be updated. So that routing information or updation information will be used in a distance vector routing table. So for that, we will be using the Bellman-Ford equation. So what do you mean by this Bellman-Ford equation? So you can see in order to understand this Bellman-Ford equations, so we have some different paths are there to reach from x to y. So what is the different paths are there to reach from x to y? So we can go to x to a to y I can reach, or I can go from x to b, from b to I can reach to y, or I can reach from x to c, from c to I can reach to y. Okay, so these are the different paths we have. So the Bellman-Ford equation, what it does is it will create an least path. It will create an least path between the two nodes. It will create a least path between the two nodes. You can see here the updated path has been given in the right side of the diagram. So all these A, B, C node, it has been represented with the intermediate called as a Z. Okay, so Z, so you can see here the distance between A to X to Z, we have represented in terms of CZ, and the distance between Z to Y, we have represented with a ZY. So the distance between two links, be it is nothing but the sum of the minimum distance which are there in the intermediate node. So that is the Bellman-Ford equation, what it tells about. So means what? If you have a different links from source to destination, means then if it is possible for us to find out the minimum cost in that link, means then we have find out the minimum cost. So here CXA, CXB, CXC is there. So among this, which one is the minimum cost? I will be represented with the use of this Z intermediate node. Similarly, from A, B, C to there is a link to Y, and which one is the minimum link is there, that I will select, and that I will call it as a DZY. Okay, so this Bellman-Ford equations will enable us to simplify, or it will enable us to find out the least cost between the two networks. Okay, the next one is the distance vector. So as I told you, what you mean by distance vector, it will monitor the distances from each node to its neighboring node. So in order to understand the distance vector, so the tree node diagram we have given in this diagram. You can see here the tree node diagram, what it is there. So whatever the previous case we have taken, no, so the tree node diagram is there. So from this tree node diagram, I need to create a distance vector for the each nodes I need to create. So how we are going to create a distance vector for each node is it has been represented in terms of table. You can see here I have created a distance vector from node A to the neighboring nodes. I have created a distance vector from node A to the neighboring nodes, so that it has been written over here. So now you can see here, see the top one A is called as a source, and here we are writing A, B, C, D. In the table you can see here A, B, C, D. These we call it as a destination. We call it as a destination. Okay, so now if A wants to transmit the data to A only, then the cost is 0. The distance is 0, obviously. If I want to transmit the data to myself, means then the distance between me and myself will be 0. So therefore in the table we have written as 0. Now you can see in the link from A to B, if I want, the cost is or the distance is 2. So therefore you can see here from A to B, if you want to reach, means the value 2 I have written in the second column. The third column you can see here from A to C. So from A to C, what is the distance? The distance is 7. So means the cost value they have written as 7. And from D it is 3, and from E it is 6, and from F it is 8, and from G it is 9. So these are the distances what we have represented at the beginning of the tree when I initiate a network. So these are the distance vector table will be created by all the nodes to its surrounding. Any doubts is there in this? Yes.
No, sir.
Okay. Okay. So now you can see here how we are going to update it. How we are going to update it. The distance vector. It has been highlighted over here. Okay, in order to update it, so we have taken another network. You can see here from A to B the cost is 2, from A to D the cost is 3, and all the nodes we have connected. So now you think about the node A. So the node A distance vector I need to create. So how we are creating? So you can see here from A to A it is 0, from A to B it is 2 is there. So therefore I have written 2. From A to C, so you can see the A to C how I can reach. So from A to C, how I can reach is that from 2, that is 2 plus 5, it will be 7, but they have written it as 8. So I think it has to be 7. I don't know why they have written this as 8. So we will cross verify it. Okay. From A to C it is 7. And the next one is from A to D. So from A to D it is 3. Why? Because it is direct link is there. And from A to E. So from A to E you can see here there are two links are there from A to E. So what are those links? The link is from A to B, B to E you can reach, or from you can go from A to D, from D to E you can do that. Okay, so they have taken it as 8. They have come from A to D, from D to E they have written. So therefore the value is 8. Okay, similarly for the F they have already written it is 8, and for the G they have written it as G. So means what? This is the first distance vector when you create an node. So that has been highlighted, and this table it has to be updated frequently as the time progress. Okay, so this is how we create a distance vector table for all the nodes. So 1 A B C D E F G, these are the nodes are there. So for all the nodes, so we have created a routing table. Okay, so how we create this routing table, that will be understood in the again next slide. So now you can see here, just 2 minutes, I will take another 2 minutes. Now you can see here uh, the, let's say, because the movement of the nodes, the network has been changed. Now you need to update the table. So what it does, so you can see here B receives a copy of A vector. So now what I want to update my table, so I will receive a means routing information from the neighboring node. So the neighboring node is, so B has received the neighboring node routing information. So it has received. So what it has received, you can see here it has received here A. Okay, A. So it has written the routing table of A. So once it receives the routing table of its neighboring node, it has to update its routing table. Okay, so now let me, I have received the routing information from Subramanya. So from based upon the Subramanya routing table, I will be updating my routing table based upon the minimum distance which I can reach from source to destination, or from my node to the surrounding nodes. I will be updating based upon the minimum distance. Okay, so that is what they have given you in this diagram. You can see here the node A is there. So from A to, this is the node A information, and this is the now currently what the old B is there, right? So this is the routing information what I have currently. Now you can see here from A to A there is a, means from A to A and the link is 0, and from A to B it is 2. So in the order of B it is also same is there. So means what, the distance between A to B is 2. Similarly in the old routing table of the B, the distance between A to B it is 2 is there. So no changes there. So I will not do any changes in the value. Now from A to C it is 8. Okay, but whereas from B it is 5 is there. So I will not change any value because the minimum distance in the old routing table it is 5. In the next one it is 8 is there. So I will not go for it. But whereas you can see here from A to D, the distance is 3 is there in the A vector. But in the old B, you can see here it is 8 is there. So means what? The distance, shorter distance has been arrived. The shorter distance has been arrived. So how I can reach from means this routing table has to be updated. This routing table has to be updated. So how I will do it? So you can see here. So if I want to reach from B to D, if I want to reach from B to D, so how I can go? I can how I can go? See here, from I can reach to A, from A I can reach to D, because from A to D how much? It is 3 is there. So therefore I from B to D I can reach from A to D I can reach from 3. So therefore the minimum distance is from the new value, it will be 5. So that is what the updated version in the new B. You can cross verify over here. The black color it has been written, right? So that is the new value. Similarly, in the right side, so you got a updation from the node E. So from the node you can see here the shortest distance from F, it has been changed to 2 value. So how I can reach? I can reach from E, and from E I can reach to F. So therefore the routing information for reaching the F node from B, it has been updated to 6.